Now here I've taken 8 questions. We'll be factorizing this. Now in the first question it is factorize 9b square minus 16. So we are going to apply this identity, that is a square minus b square is what? A plus b multiplied by a minus b. So that's what we will do here. I can write this 9b square, right? We have 9b square can be written as what? 3b the whole square. And similarly, we can write 16 as what? 4 square. So for as for the identity, we have this as A and this as B. So it can be written as first term plus the second term, that multiplied by first minus second, right? Now we can see that the second one can also be done using the same identity. Let's check for this. This can be also solved using the same identity. So here, first of all, we can write 81 as what? We can write, look into this properly. Here I mean to say that if I talk about this part only, what I can write this as? We can write this as 9x squared the whole square. Why? Because we have the power raised to the x raised to the power 4. Now, similarly, we can write y raised to the power 4 as y square whole square. Now, here we are going to consider this part, right? Just 9x square as x and y square. Sorry, not x, a. So taking this as a and this is b, we can apply this identity, right? So it results to give you what? A plus b, right? A is this thing, whole thing, plus b, and then a minus b. A is what? 9x square, and b is not y here. Make sure it's y square. Now, what you can observe that here the first part, right, this is cannot be factorized, but this can further be factorized using the same identity. So since this is cannot be factorized, we can write this as it is. This is 9x square plus y square. Now for the other part, we can again factorize. So what we can write this as? We can write 9x square as what? 3x the whole square. And similarly, we can write y square as y whole square. Now this time we have this as a and this as b. So applying the identity, this as we know that cannot be factorized. Here we can factorize this using the identity, that is 3x minus y multiplied by 3x plus y. So this would be the answer after factorizing the expression. Now moving to the next question. But before that, I will do this part because I can see that this is also based on the same identity. So here our question is 256 x raised to the power 16 minus 1. Now, we are going to do in the similar way. We will look for the square term. So 256 is what? The square of 16. And I have to write this as a square of number. So that means I should write 8. Look again. Here I can write x raised to the power 16 as x raised to the power 8 whole square. Well, 1 square is 1 only, so we can write like this. Now, here we are going to consider this whole thing, that is 16x square, as what? A, and 1 being b here. So applying this identity, a square minus b square, we can write as 16x raised to the power 8 plus 1 and 16x raised to the power 8 minus 1. Keeping this as it is, that is 16x raised to the power 8 plus 1. We can factorize this further, the other expression. So this can be factorized as what? I can write this as a square of a term. So I can write this as 4x raised to the power 4 whole square, right? One more time. X raised to the power 8 can be written as x raised to the power 4 whole square. Well, 1 is always can be written as 1 square. Now, we cannot factorize this expression as it is already factorized. Now, this can further be factorized using the same identity, that is a plus b into a minus b. So we can write this as what? As 4x raised to the power 4 minus 1, or say plus 1 first, and 4x raised to the power 4 minus 1. Now, similar to the previous part, you can see that this can be factorized further. So keeping everything same, that is, we have 16x raised to the power 8 plus 1, and this will be as it is, but this can be factorized. And how we are going to factorize this? Writing this as what? 2x square, the whole square, and 1 like 1 square. So check now what we can see that keeping everything same. So this is 16x raised to the power 8 plus 1. This should be written as 4x raised to the power 4 plus 1. But after factorization, this will become what? This should become 2x plus 1 and 2x minus 1. That's how we will do this question. Now coming to the next. Next, we will do second part over here, third part, right? So what is the question in this case? We have x square minus 11x minus 80. Now check here, we have to factorize using middle term splitting. From the factors of 18, we need to split 11. So we can see that 80 can be written as what? 16 into 5, right? So this is how we are going to do. So it'll be, since we need minus 11, we'll be writing minus 16x and plus 5x minus 80. Now taking x common from the first two terms, we get x minus 16. Similarly, taking 5 common over here, so we'll get x minus 16 again, like dividing this by 5. So we can see x minus 16 is common throughout, and therefore we get x plus 5 after taking common. So this should be the simplified form, and we have done middle term splitting over here. Moving to the next question, say the fourth one over here. Now need to observe, let's first write down the question. We have 2x square plus 7x plus 5. So here we are not going to get the factors from 5 alone. It should be product of 5 into 2, that is 10. So from the factors of 10, we need 7. So that's very easy. 5 into 2 is 10, and 5 plus 2 is 7. So that's what we are going to do. So this is 2x square, and we are going to split 7x, and write it as 5x plus 2x. You can write 2x plus 5x as well. Now from the first two expression terms, we have x as common, so that results to give you 2x plus 5 on dividing. And for the last two expression, we have nothing common, implies we can take 1 as common, so that also gives you 2x plus 5. So we can say that from here we have 2x plus 5 and the other part as x plus 1. So this is how the fourth question can be done. Now moving to the next. So when I see the next one, this you can see that it is a biquadratic. That means we have a power as 15. So, but it can also be solved in the same manner as we did, that is by middle term splitting. So plus 3x square minus 18. But the rule of factorization is that before started to do split them into different factors, we must try taking common, which is there. Like I can see that from 15, 3 and 18, what is common? 3 is common. So if I take 3 as common, it should give you how much? 5 times x raised to the power 4. This divided by 3 is what? X square minus, this is 6, right? Now check here, there is nothing over here, implies that we have 1 over here. So from the factors of 5 into 6, that is 30. From the factors of 30, we need what? 1. So that's easy to get, that is 6 into 5. Now 3 will remain outside. So what we can write over here, this is 5x raised to the power 4 plus. Remember, we apply this property, factorization for class 8 standard, only when the power is 2 or 3, and not in a case when you have power as 3 or 5. So let's continue with this. As I said, we can we can split this x square, that is, we can write this positive x square as what? I am going to split this as a factor of 6 and 5. So I can write this as 6x square minus 5x square, right? Minus 6. Now, continuing with the same way manner, we are going to take common from the first two term. I can see that we can take what? X square as common, right? On taking x square as common, we are left with 5 times x square. One more time. Since we have taken x square common from here, dividing this by x square should result to give you 5x square. And dividing this by x square, we are left with only 6. From the last two term, nothing is common, so that means minus 1. And you know should know that if there is a minus sign before the term, we must take minus as common. So dividing this by minus 1, we are going to get positive x square, and dividing this also by minus 1, we'll get positive 6. Now 3 is outside, and then we have this thing is common from inside. So that means if I take 5x square plus 6x as common, that results to give you x square minus 1. That's how this question can be done. Now let's move to the next. We are now on sixth question, right? So the sixth question is a cubic polynomial. This is 12y raised to the power 3 minus 14y square minus 10y. Now what you can figure out from here that, as I said, we should take common whenever it is possible. I can see between these, we have 2 as common from 12, 14 and 5. And from y cube, y square and y, we have y as common. So taking this as common, what we'll get inside? We'll get 16y square minus 7y and minus 5. This is what comes inside. So when I take 2y common, we got 16y square. Dividing each of them by 2y, we get this. Now what we can do further is to factorize the expression inside the bracket, that is by middle term splitting. 6 into 5 is how much? 6 multiplied by 5 is 30. And from the factors of 13, what we need? 7. So how to factorize this to get 7? So need to see that if you factorize 30, it has factors like 2 into 15. And if I split it further, right, with 3, we are getting 5. Now we can see 5 into 2 is 10 and 10 minus 3. So this way I'm going to get. So this is 6y square. I'm going to write minus 7x as what? Minus 10x. Sorry, no, it's not x, it's y. Minus 10y plus, right, see here, that is 3y. And then minus 5 is there only. So this 2y get cancelled. What is the common between these two terms? There is y common and 2 is common. So if I take 2y as common, so if I take 2y common from these two, we are getting 3y minus 5. And similarly, we can take positive 1 as common. That also give you 3y minus 5. This is 2y. And if I take these two common, that is 3y minus 5 as common from here, what it gives you? 3y plus 1. So this is the factorized form. Now, as far I remember, we are left with the last part only, that is this one. So let's figure out how can we do that question. So here the question is what? This is 16x square minus 24x. This is yz minus 16y square minus 16z square. Now, what you can see that we have to just figure out, can we frame an identity from here? So there are 3 square terms, right? It is the non-square terms generally gives you the hint. The non-square term is this, and it is composed of y and z. So identify y and z. Yes, that means that we are going to frame an identity from these 3 expression in general, right? So let's say keeping them together, keeping 16x square as it is, and I can see that if I take minus, what is common here? No, nothing is coming common, so minus will be only taken common. What we are left with, first time writing this, this is what? We can write either any of these square terms, right? So if I take this as, so after taking minus common, we are left with 9y square. And this is coming to be what? This can be positive 224yz. And this is what? This will be again positive 16z square. Now we can do apply identity over here. So let me check whether, yeah, these are two square terms, so we can apply identity. So let this be 16x square minus, this is a square term, so what we can write this as 3y whole square. And similarly, look for this one. This can also be written as 4z whole square. Now applying the identity of a plus b whole square, right? This is a square, this is b square, and the middle two terms should come as plus 2 times a, which is first term, multiplied by b, which is 4z. Now cross check, are you getting back 24yz? Yes. So you can cross check that after writing them in the form of an identity, are we getting back 24yz? So it is. So we can now say that this is 16x square minus, this can be written as what? 3y plus 4z whole square. But that's not the end of the sum. We can see that it can further be factorized. I can write 16x square as what? 4x the whole square. And this is also already a square term, so should be written as it is. Now, considering this 4x as a and the other as b, what we can write this as a plus b into a minus b. So a is this plus b, which is this, and then a minus b, a which is this again, and my 4x, sorry, a is this minus this, so that will give you minus 3y and minus 4z, right? That will be the factorized form of this question.